Not a guitar, but a table. The first table I've ever seen built this way, and it was really difficult to pull off. We're building this table out of these two big Clara walnut slabs and roughly 20 pounds of copper wire, which we'll eventually get to, but first thing to do here is to get these slabs flattened. We've had these slabs sitting in the shop for a while. They have some really good figure in them, like gun stock quality walnut, and I considered making some kind of guitars out of them, but they're huge and have these really cool live edges and voids, so I thought it'd be kind of a travesty to cut these larger slabs into smaller pieces to build guitars out of, so we're building a table. My buddy Packard, who's helped out here and there on projects in the past, is once again lending a hand to work on this project with me. There's a bunch of tables being built, and I'm sure you've seen them, where the voids or live edges are turned together to form a river, which then gets filled in with epoxy, and they look pretty cool. I've sort of done a concept with this with the guitar in the past, so we thought it'd be cool to make a design like that, but to fill the voids and the live edge with copper instead of epoxy. If we were to just join the live edges together, we'd get a really big middle river section, which would be cool, but it'd be way too big a piece of copper to fill. So we ripped the straight edge down the live edge while still leaving some of the natural edge, and that leaves us with two smaller voids to fill instead of the one giant river down the middle. Got the two slabs glued together and clamped. Then we routed out cavities on the back side of the table directly over the voids. The idea here is that we can plug the voids from the backside so that when we make our copper inserts for the top, we only have to make them like a 1/2 inch thick instead of the full thickness of the table. We could have just filled the voids with epoxy, which would have been a lot easier, but the goal here is to make a copper river table, so using as little epoxy as possible on this project was important for us. We used some random pieces of walnut that we had in the shop to make plugs for these areas, and got them glued and hammered into place. There's a lot of color variation in walnut. Some of the pieces we used as plugs are quite a bit lighter than the table, but it doesn't really matter considering this is going to be on the bottom of the table, so you'll never really see it. Took some Total Boat high performance resin, mixed it with some graphite powder to turn it black, and filled in some of the smaller voids on the bottom. Now that we had our plugs in place, we could square up the edges of the table and get to working on filling in the voids with copper. So the purpose of slightly carving out the voids is to make sure that they don't have any undercuts, since we need to be able to drop our copper pieces straight into the voids. If they have undercuts, then they won't drop into place. Two of these voids went right up to the edge of the table, so we decided to cut out the sides where the void meets the edge so that we can drop the copper inserts down the side of the table. This will kind of give a wrap effect or a little copper waterfall look to the table. Also, this will give the appearance that these copper inserts are actually the same thickness as the table, which they won't actually be, but that'll be kind of a cool aesthetic. Then just cleaning up these pockets and coating them in epoxy to get them ready for the copper. Aside from getting a copper sheet and cutting that to shape, there's really only one way to fill these cavities with copper. You might have seen videos where people fill wood voids with aluminum, and I'm pretty skeptical of the whole thing. I think they might be using lead or zinc or some other metal with a lower melting point than aluminum, because molten aluminum is going to burn and char the wood if you poured it directly into a void. So if molten aluminum at roughly 1200 degrees Fahrenheit is going to do that, imagine what molten copper at 2000 degrees is going to do to wood. It's just going to set the whole slab on fire. So the method we're trying is to fill the voids with silicone and make a plug. The silicone we're using has a shore hardness of 70, which is similar to the hardness of a rubber sandal. We also added a small dam surrounding the void so that the silicone casting comes out slightly thicker than the void itself. Now we can take that silicone plug and put it in a wooden box and make a sand mold out of it. This is Petrobond. If you've been following my journey into casting metals here on my channel, you'll know that I use this stuff a lot to make casting molds. It's a mix of clay, sand, and oil, which makes a kind of tacky and formable substance. This is a two-piece mold, which means that we have our plug, which we're going to cast in the bottom mold, and then we sandwich on a box of Petrobond on top, which seals the casting and allows us to add a hole to fill the mold with metal. Then we cut out a gating system, which is going to let the molten metal flow into the cavity of the mold. Put the top back on, and we're ready to give it a shot. I chopped up a few pounds of some copper wire to melt down, tossed it into the crucible, and lit up the furnace. And after about an hour, we were ready to pour. One thing to keep in mind here is that we're trying to pour pure molten copper, just straight 100% copper. If you saw my last guitar build, you'll know that I had some difficulty getting copper to cast correctly into a guitar neck, but my thought was that since these pieces were much smaller than a guitar neck, they'd be easier to cast, and I was simply wrong. We tried and tried again and again, and I think we did 10 or 12 different sand molds with varying runner and gate designs. Alright, these are some of our mini attempts at casting copper. This one's a pretty typical result for us right now, which is not good. This one's a little bit better, but still totally unusable. We also tried adding a small amount of phosphor copper to act as a degasser, which did not seem to help at all. This was the closest we've come to a usable copper casting, but even this one's got voids on the edges and isn't good enough to use. All three of these are filling straight down into the casting. We tried some with runners instead, and they weren't any better. So despite our lack of success pouring copper, we continued on with prepping the rest of the voids on the table to fill with silicone. We did a ton of research on casting copper, and it seems the general consensus from our research is that pure copper is just really challenging to cast. I think if we wanted to give ourselves the best shot for getting good results from casting copper, we would need to invest in a thermocouple so that we can measure the temperature of the molten copper. For casting copper, the pouring temp is really critical, and we currently have no way of knowing what temperature we're pouring at. So it's impossible for us to replicate pours or to diagnose our failures when our parameters are potentially varying so much from pour to pour. Thermocouples that can read as high as we need for copper, which would be in excess of 2,000 degrees Fahrenheit, cost thousands of dollars, so that's just not an investment we're willing to make at this time. So with all that said, we ultimately made the decision to once again switch from pure copper to bronze instead. And we did this just by adding a small amount of tin to the molten copper, about 4 to 5% tin, so a little bit leaner of a mixture than what I used on my bronze guitar. This should make it slightly more workable than if we went with a more rich mixture of say 10 or 15% tin. Alright, I got a little chunk of tin here, 7.5 ounces. We'll add this to about 10 pounds of copper wire to make our bronze. First attempt with the tin added in, and both of these castings came out perfect. Very little pitting and the edges look good all around. So now we just gotta cast the rest of these. Now we're on to making the larger insert for the middle of the table. This is the largest insert we'll have. I mentioned earlier that the reason we cut a portion of the live edge off was to make 2 smaller voids in the middle of the table instead of one large sort of river-like void. The main reason we did this is because it would take an incredible amount of Petrobond and a really giant mold to create an insert that's the length of the table, and even though bronze is drastically easier to cast than copper, it's still challenging to cast such a large piece. Now that our insert in the middle is significantly smaller and shorter, it's still a large bronze casting, but one that should be doable. The challenge here is getting the bronze to flow all the way from the pour spout to the other end of the mold. We're not able to preheat our sand molds since they're so large, so the bronze is rapidly cooling as soon as it contacts the sand. We carved out a recess on the top of the mold, which effectively gives more volume to it in the hopes that this would keep the bronze molten long enough to fill up the mold, but alas, it did not.
Not even close.
No. So 4 hours and a new sand mold later, we tried again. This time we placed the mold on a more aggressive slant, which should help the bronze flow faster to the end of the mold. Luckily, this second attempt came out perfect. For the inserts that go up to the edge of the table, the plugs have a lot of flexibility in them because they're made of silicone after all, so we needed to come up with a way to brace them for the sand mold. Our first attempt here was to weld up some L brackets that the silicone plugs will sit on, and the brackets will provide that extra rigidity which will allow us to pack sand on top of them without deforming them. And we tried that, but we just weren't able to get the plugs to release with the metal bracket cleanly. So our next attempt was to split the bottom of the mold into 2 pieces so that the plug was pushed up against the side of the mold, made a separate smaller mold, and then we pulled out the plug and attached the smaller mold to the end of the larger mold, which gives us a clean cavity to cast. and these pieces also came out perfect on the first try. So at this point in the build, we are pretty ecstatic to be done with the casting process, which took way too long. We were under the impression that that was going to be the most difficult process in this project, but we were sort of wrong about that. Since we added about an 1/8 inch base to the plugs, we first had to grind off that 1/8 inch of bronze so that the inserts were the correct thickness for the voids. This ended up being a really time-consuming process. It's pretty easy to tell how far we needed to grind down on the inserts, but getting them flat and level is the real challenge here. So we've got this insert pretty well ground down, and you can see when it sits in there, it's just got a little lip on it, maybe like a 1/16 inch. But the trouble now is getting it down to the exact same level as the walnut. We can't just grind on it here because we'll end up chewing away at the walnut too, since bronze is so much harder than wood. We'll just end up with a mound around the bronze, and then getting it leveled down outside of the cavity is going to be nearly impossible to get it perfectly level without a reference for the wood. So this is the conundrum we're facing right now. Here's what we decided to try. We glued in this small insert with high performance epoxy, once again mixed with graphite powder, let that cure, and then we took this 4-flute spiral bit, which is made for an end mill, but we put it in our big router, set up a sled, and just ever so slowly routed, or I guess milled away at the bronze. We're talking maybe a 32nd of an inch per pass. All right, milled this piece down and gave it a quick sanding to see how it looks, and I think this method's gonna work. It's just gonna take a long time. So we went ahead and glued in the rest of the bronze inserts so that we could get them all leveled down to the walnut. Routing or milling bronze using a router is not something I'd recommend. I will say it worked a lot better and it went smoother than I would have thought. But all it would take is one accidental bump further into the cut to potentially break the bit and send it flying. So this was a full focus process getting this bronze milled down, but we were kind of out of any other ideas. A typical mill isn't going to have a large enough throat capacity to fit this table in it, so our backs were kind of up against the wall with this one. Another reason we had to work so slowly was because of heat buildup on the bronze. If we milled the bronze too fast, we run the risk of it heating up to the point where the epoxy begins to melt, and this could potentially send our insert flying out of the cavity. Luckily it all worked out, but since we're going so slow with the milling, it took around 4 days to get all these inserts milled down. Here's another method I wouldn't suggest replicating: using a circle saw on bronze to square up the edge pieces. Once again, taking like just a 64th per pass. This also worked surprisingly well and is kind of visually pleasing to watch, but probably not something that should be done with woodworking tools. For the legs, we took a couple pieces of walnut. These are really nice pieces of walnut with a lot of figure in them. Cut them into rectangular blocks and also cut an angled top and bottom on them so they'd mount at a slight angle. Routed them to shape using a template to give them a bit of an hourglass shape. Filled some of the voids with black epoxy. Got some threaded inserts installed for mounting them to the table, and put a little bevel on the feet of the legs, and these were pretty much done. Just need to get some finish on them. Routed out a slot for the C-channel on the bottom of the table. We got mounting hardware from a local shop, which basically consisted of C-channel and mounting plates for the legs, all powder-coated steel. Alright, so now we're back to the issue of getting these bronze inserts flat and perfectly level with the table. As you can see right here, they're not. First we tried just hand sanding with a block, and that was incredibly slow progress. Tried the belt sander, but it was just too difficult to be consistent with it. Best method we came up with was jerry-rigging a sander by ripping off the stock sanding block and replacing it with a chunk of MDF with sandpaper glued on. This gave us a giant, flat, vibrating torture device. Less physically demanding than hand sanding, but pretty much a one-way ticket to instant arthritis instead. The stock sanding block is rubber and absorbs a lot of that vibration, but with our DIY wood version, absolutely none of that gets absorbed, and this took us around 4 days to get completely leveled. So a really time-consuming and less than enjoyable process, but it worked, which is all that matters. Mixed up some more black resin to fill some of these small hairline gaps that opened up around the inserts due to the sanding. Also used some super glue to fill in some of the small pinholes on the bronze so we have a nice smooth surface everywhere. And then back to sanding with the block on the sander. Also used a sharpening stone on the bronze to do one final leveling on it. Added a round over to the table using a carbide bit, which seemed to cut through the bronze just fine. And finally, we added our first coat of finish. We're using a hard wax oil, which you basically just spread on the surface, give it a few minutes, and then wipe the excess off. Did that on the top and bottom, and now you can really start to see this grain pop on this black walnut. Once it cured, got it scuffed up with a Brillo pad, and then started on polishing the bronze. For the most part, we used some cotton wheels on the Dremel to do the majority of the polishing. Use some tape barriers to make sure we're not polishing the wood, which would give us an uneven finish on the wood. This was pretty difficult to get a really even polish on it. It took around 3 days to get polished, but I think it was well worth the effort because the polished bronze really stands out contrasted against the walnut. One final coat of hard wax oil. This finish doesn't provide any protection for the bronze, so it's basically a living table as it stands, which will patina over time. I think that's a cool feature, but we could also apply a ceramic coating to keep the bronze as it is currently. Bolted on the legs, and here's the final table, the first Burl's Art table. Different kind of project than usual, but I think it captured the idea we were chasing. Although it was way more difficult than we had anticipated. Probably not going to use that exact method again going forward, but in the end, it did work out and made a nice looking coffee table. This table is posted for sale on my site. Got a few guitars also listed. I'll be back again here shortly with a new guitar video. Thanks for watching.